Hello, and welcome to today's lesson. We're now moving into our area volume unit. So today we're going to look at some of our basic shapes. So by the end of this lesson, we're always looking at our essential learning goals to start out. So by the end of this lesson, we'll develop the concept of area. How do we find what an area is? What does an area represent? And we will derive the formulas for the areas of a rectangle and the area of a parallelogram. And we'll apply these area formulas to solve some problems. So now, when we look at the area formulas for rectangles and parallelograms, what we have to understand is we need to calculate this space. And when we're talking about two-dimensional space, what we're talking about is breaking a shape up into little squares, and the squares have to have the same unit measurement on either side. They can be inches, they can be feet, they can be meters, so the measurement that we use isn't as important as making sure that we're using the same measurement in both directions to divide these shapes up into little pieces. So now, when we look at where area is used most, we can talk about carpenters or any construction workers looking at the areas of a room, areas of walls, floors, roofs for construction. If we look at decorators, they need to know the area of the floor, the area of the window, to know how much carpeting or drapery they would need. So when we're looking at a rectangular shape or a parallelogram shape, what we always need to find is we need to find the base and height of the object. And if we're dealing with a rectangle, our area formula is a very simple formula. It's area equals base times height. Okay, we're multiplying the length times width, or base times height, to get the area of that shape. So now, here's an odd question. We're only dealing with rectangles, but how can we find the area of this hexagon below? And if we can only work with rectangles, it seems weird to be able to say we can find the area of this hexagon. But what we can do with the hexagon is we can break it into rectangles. Okay, we have our middle rectangle here, and we can find the area of that rectangle, 4 units high, and we've got 1, 2, 3, 4, 5, 6, 7, 8 units across. So if we're looking at the area of this hexagon, just that middle rectangle, area equals our base measurement of 8 times our height measurement of 4, and we know that this middle section has 32 square units. We don't know what the units are. Are they inches, centimeters, millimeters, meters, yards, feet? Okay, but we know that there are 32 squares if we go through and count all of those. Okay, now, one thing you always want to think about is, can I make rectangles? So if we look on the top here, we've got 2 triangles that we can cut apart, and we can put them together to make a rectangle that is 1 unit high and 4 units for a base. So now we've got an area of base of 4 times a height of 1 equals 4. So now I've got another piece that we can work with. Okay, we also have 2 triangles down below. And, we're going to see how this triangle area formula works a little bit more in our next lesson. But just dealing with rectangles and parallelograms, now I've turned into a 3rd rectangle that has a 4-unit base and a 3-unit height. So when we find the area of that piece, we've got 4 times 3 equals 12. And now I just have to add these pieces together. 32 plus 12 is 44. 44 plus 4. The total area of the hexagon is 48. Okay, so we have the 32 plus 12, which gets us to the 44. 44 plus 4 gets us to the 48. And we've solved the problem we've solved the area of a hexagon. Okay, my eraser's kind of going wonky on me. Okay, we solved the area of this hexagon by working with rectangles only. Okay, so now, parallelogram formula is basically the same thing. We need the base of the parallelogram, and we need the height of the parallelogram. The reason why this formula works is, once again, I can cut a triangle off of the one side, and if I move it over to the other side, I haven't changed my base length, I haven't changed the height, and I've just turned this shape from a parallelogram into a rectangle. So that's why, if you notice, we don't talk about length times width. We talk about base and height because those two measurements are the most important measurements when finding the area of any shape. So we want to be careful here. We don't want to focus on what we call the slant height of the object. Okay, we have to work with our base measurement, which can either be on the bottom or on the top, and the height. And the area formula is the exact same area formula as a rectangle. Okay, so now, finding the area of this given parallelogram, I've got a base of 10, I've got a height of 7. Remember, base and height have to be perpendicular distances, so my area is going to be base of 10 times a height of 7 equals an area of 70. Now, what you have to be careful of is if you're ever given a slant height, you might have to use Pythagorean theorem with the right triangle, a squared plus b squared equals c squared, to find the measurements of that missing piece. Okay, now, we can work these problems backwards. You know, we have three pieces in the formula. Area equals base times height. So as long as we're given two of the three values, we can always find the third. So in this case, the height is the question mark. It's what we're looking for. So then we have to plug in what we know. We know that the area is 7.13. We know that the base length is 2.3, and that base length is multiplied by h. So now we're getting into what we call a solving problem. And whenever we solve, we have to undo the operations to get the variable by itself. So when we're looking at this scenario, trying to find where my calculator went here on me. Okay, when we're solving this situation, what we have to do is we have to undo the multiplication by 2.3. So we're going to divide both sides by 2.3 to get h by itself. So we have 7.13 divided by 2.3, and we get our height measurement of 3.1, and in this case it would be meters. In most of your problems, the units are there for you, but you always want to think about and consider units when you're solving problems. Okay, now, you're actually going to see this one in homework today. And what we're looking at here is we're looking at making the estimation. We're trying to estimate how much paint we need to cover X number of rooms, you know, for a motel. What we have to be careful of here, and this is what happens most often, is pulling the wrong measurement, because this is actually just finding rectangles. Okay, so what we have to do is we have to look at the front and back wall. Okay, the front and back wall are both similar rectangles. And those rectangles are 14 feet for a base and 10 feet for a height. So each of those walls individually has an area of 140. Then we look at the left and right side walls. Okay, now remember, we're just finding the area for one of the walls. We have to remember that there's two involved here. Okay, we've got a base length of the wall on the sides of 16. The height is still 10. Okay, so we have 160 for both of those, and we're going to have to multiply both of these by 2 because there's the front and the back, there's the left and the right. So we've got 280, we have 320, and then finally, the last piece that we have, the four walls and the ceiling. Okay, the ceiling is one spot. Okay, we're not painting the floor. And the dimensions of the ceiling are 14 by 16. Okay, so we have to multiply those two pieces together. So we've got 14 times 16. We've got 224. And then we have to add up all of those pieces. 280 plus 320 plus 224. And we have 824 square feet per room. Okay, we also have to understand that we're painting 148 rooms. So we need to multiply that by the 148 rooms. Okay, and we've got a lot of square footage that we are painting. We are painting 121,952 square feet. Okay, so those are our units there. Okay, and then when we look at coverage of paint, okay, 1 gallon of base covers 500 square feet. So what we would do is divide this by 500. And what we have to be careful of here is we can't use the decimal value. You can't go to Lowe's, Home Depot, Menards, and say, I want to buy 243.9 gallons. Okay, that's not going to work. So when we're looking at these estimations of amounts, what we have to do is we have to take our value, and it doesn't matter what the value is. If it's a 0.1, if it's a 0.001, you need to always round up to the next amount. So we need 244 gallons of base paint, and then we would do the same thing for our finishing paint. We would take our square footage, divide by 250. So our square footage of 121,952 divided by 250. Okay, we need 488 gallons, or if you notice that there's a doubling component between the two, you could do that as well. But we need 488. Remember, it doesn't matter what's after the decimal point. As long as there's something there, you have to go up to the next value. And that concludes our lesson for today on finding the area of rectangles and parallelograms. Thank you and have a good day.